Hi everyone, welcome back in day one. So today we are doing the continuous our master agentic AI skills in 2026 to continue to the next day one chapter for the RAG. So RAG is the one of the important in the agentic AI. So how it's work, uh, how this technology that bridges the gap between the vast and but a static knowledge of LLM and the specific up to the minute date your application needs. So let's go to the RAG slide. So what is a RAG? So why the RAG is very important when you are developing the LLM model. So basically, exactly, if we can say what is a RAG. So RAG is the retrieval augmented generation is the process to optimize the output of a large language model. So its reference for the authoritative knowledge base outside of its training data and source before generating a response. So this is a definition for the RAG. And think for this way, let's suppose we have the traditional LLM model. So we are like we have a one brilliant students who only knows what they learned in a school, but RAG is like giving the student access to a perfectly indexed private library right before they answer a question. So the key takeaway here for the RAG is extend the powerful capabilities of LLM to specify the domain like the company internal documents. So I'm taking one more example. So let's suppose you're working in the one of the organization and they have some HR policies and rules regulations there. So now you have to implement the LLM there. So whenever the user will be go and they want the company policies only. But here the LLM is here. So LLM give the all the because LLM is trained on the big large data. Okay, that is available on the internet on the web sources. They access the Wikipedia and all these internet things. But my company policy they don't know because that is not available on the internet, maybe because of it's my company. So here what we will be give them, so we will give them some database. That database will be connected with the LLM. So whenever the user will be query something related to the policies, so they will be go to the my database and they will be search specific things and they give the answer. So here there is and the now you can see the accuracy. If someone will be asked the company policy before the RAG system where we're putting, so it will be give the hallucination answer. It's not giving the correct answer, but it's try to give some answers. So that answer is wrong. You have to put your database and from your RAG system and your RAG using your RAG system, the LLM will be give the exact answer about that one. So here what is a problem in the traditional LLM? So traditional LLM is a static training data and causing the outdated or incomplete answer. So what that mean of the outdated or incomplete? So let's suppose I'm using one LLM model and that LLM model is trained till December 2025. That model is not trained in the Jan 2026. So his knowledge is limited to the December 2025 only. But now I'm working in 2026. I need the exact answer of what happened in the world in the January 2026. So how they will be give? No, they can't give it. So what we need to do then? What we need to fine tune the model again. We need to go back to the with the model, and we will give them learning. But this learning is very is very expensive, because you're fine tuning all the model from the beginning, so that is very expensive for the organization. So what the organization will be do, they will be put one RAG system there, and that RAG system will be help them to learn new things. So they are adding additional data using the RAG system. So what is a problem in the traditional LLM? So we have the static data, static knowledge base. So because of that one, static knowledge. So what we have limitations of when model is trained. Second, knowledge gap. LLM are trained on public internet data, so they cannot access specialized and the private sources like your company's HR policy or confidential research papers. And finally, the most issue is coming the hallucination risk. Hallucination risk is because the model is trained to predict the next most possible word. When it encounters the knowledge gap, it doesn't sound like correct. So he didn't say I don't know. He's predicting, he's giving something answer to you. So whenever you're writing anything, so he's trying to give you answer, okay, like in the normal LLM bot. But this is a wrong. So if you're working in the organization and they are saying that they're giving the hallucination answer, it's not correct. The user is not satisfied because they want the specific answers. So this is problem in the traditional LLM. So then the RAG system is introduced. So RAG is the elegant solution to this problem by introducing an external knowledge base. RAG delivers a three massive improvements. So what that improvements? So improvements is improve the accuracy. So because response are now grounded in the facts, and the LLM is forced to use the retrieved context, and reducing the risk of hallucinations. And second one, information is currency, correct? So your knowledge base can be updated in real time. The LLM now can access a data and emerge after the training cutoff and keep your AI application fresh and relevant, correct? So, and critical one, source attribution, because the LLM is usually specific documents to formulate its answers, correct? So you can cite those documents, and these transparency builds the trust. So if you're referencing some document, they're saying that yes, I referencing this website for this answer, so this is very good. So now then user can be trust on you. So that is the attribution is very important, and is allowed to easy to fact checking, and RAG is make a AI answer verifiable, means it's verifying. So now the RAG, how the RAG architecture will be work. So if you see in the first slide, so here we have something data, and in this data we have here the data set, and that will be pre-training, okay, that is pre-training. It's going to the base LLM, and that will be response to go to the question and answer system, and that query go to the users. Here we have that model, okay, here we have the our system, our database. So this database, we have something like we have the HR policies, okay, we have the company's policies, so we have company data, let's suppose, okay. So the model will be go there, and they will be search, yes, the user query these questions, so they will be search from here. Then they will be go to the base LLM, and the base LLM will be go to the pre-training model, and then they will be give the answer to the user. So this model will be work very perfectly, okay. So this will be give the users more flexibility. So here we have this more fine-tuning model is here. So first user will be query, and that will be go to the featured LLM. Then after that featuring, there will be search for the what domain specific data set they are looking for. Then it will be go to the base LLM and then pre-training model, and this structure will be work. So this model will be help us. So let's suppose we have some raw documents like PDF, web pages, and data set into the system. So next they will be split a large document into smaller chunks, and this is crucial because the smaller chunks leads a more precise retrieval. So then there comes a magic word that called the embedded each chunk. So embedding is very important. So we will go through the embedding, how we are doing the embedding in the machine learning. So we are going there, and we can see how we need to do that. And then we have the after an embedding model converts the text into the high dimension numerical vectors, and these vectors initially is the mathematical representation of text and meanings. So here after that there will be transferred to the that models, and then that vectors will be transferred and stored into the model. So here we have the vectors. So here we have the vector embedding. So let's suppose one of the keywords apple. So apple is the weightage that you can see in the numerical one. So text into the high dimension numerical vectors, and these vectors in mathematically representing the text meanings, and text with the similar meaning have the vectors that mathematically will be calculated to the each other, and finally stored to the vector database, and that database is optimized nearest neighbor search, allowing us to find most relevant chunks in a milliseconds, and these complete the authoritative knowledge base. So this is how the RAG system will be work. So let's see some example. I'm creating one example. So this is my GitHub repository. So all the content I will be update here. So I will be share this GitHub repository in the link. So this one is the link for the day one. So this is a RAG day one. So we will cover this one here. So how it's work, and let's write one create one model here. So I'm using the here one of the Gork. The Gork is a very good LLM model I'm using here. So this is a Gork. You have to log in, and then you need to go to the API key, because I need the API key here. So first I'm importing my model here. So pip install Grok. So Grok model I need to import it here. After that I'm importing my OS, import OS, then operating system, then from Grok import Grok. Okay, so after that I'm not using ChatGPT or Gemini here. I'm using this model because it's key here. So Grok, then API key, simple. This is very simple to write API key. So API key, then you have to mention your API key here. So okay, so first I run this model, then G we will capital, yeah, G is capital because your model here we have the core capital. Then I'm going to my model, and let's copy this code. Now I'm pasting here. This is my API key is working fine, and let's go down more. Okay, so it's working fine here, and now next is we need to create some data. Okay, so let's suppose I'm creating one my data related to the some text we will write, and here I'm writing my prompt. prompt is very important. Prompt is very important for the LLM bots, because that will be give you the exact answer if you're writing the exact prompt. So nowadays, more focus on the prompts. More accurate prompt will be give you more accurate data. So I'm writing something here to extract for dummy. I want to create. So I created the data. Then we have write it a prompt. Prompt is write a one paragraph making a description for this data. So here I will be put my data. Now run it. So now this prompt and data is created. After this, now let's go for the model. So we need to call our model. So this is the I'm writing the completion. Okay, and my client dot chat dot completions dot create. So we need to create our model. And which model we are using? We are using the let's suppose they helping us not this model. So we are creating the model equal to which model? LLM llama 3.3 versatile. Yes. And what we need the messages. What message we need the one role for the user. And so first we will write the role, then it's like a dictionary. So role is user. So user. Then we need to write the content for the content. So we are writing the prompt. Whatever we are given the prompt, so give it to the answer. Okay, so this my model is now function of this. Now simply I need to print. So what I need to print, let's suppose my response, my response. Okay, so like I'm creating more. They will be write first this, and then after that response. So what we need the let's suppose completion dot choices. So choices we already given to them, so 0, and dot message dot content. So now they will be give the message of that content. So here we have a my response. In the my response, you can say we write it at write a one paragraph marketing description for this. So they will be give the marketing description for mid-century office chair that made in Italy and aluminium base and 5 wheels they have. So they're writing full description for this one. So this is generated by the LLM. Evaluate the workspace, the timeless elegance and mid-century office. So it's very good. So these bots are giving the very good response. Now this is very simple. We have created the one LLM model, and we are we write it some prompt, and we are they're generating some prompt. Now where the RAG is there. So now if we are using the RAG system, okay, so now in the RAG system we will make something data. Okay, so some database there to so I'm importing the so now we are creating the RAG system. So how we need to create? First we are importing the our library. Again we already imported basically, but if we are okay, we're calling again our library, and then after that we need some database. So my database is here. So this is my knowledge base. So my database is here. So database. So after this we need to the database. So this is my database. After that, what we need the which query the user looking for. Let's suppose we are creating our RAG system here. So this is my RAG system. So how it's work? So let's suppose we have some vector data. So vector data is basically we are saving everything in the keys, yeah, on the vector space. Okay, this is vector database. So I'm creating simply one query here. So this is query equal to, so let's suppose they will be query about one of the chair. So because this is related to the chair data, so I'm writing the context. So let's suppose my context is knowledge base. So here we have database, and that database have the query. So database have the query. Then after that the query, if they have the data. Okay, so like we write it query. So in the database, if we have query, so they will be give from the knowledge base, and they give the information. Okay, so this is done. So this is my knowledge base I given to according to the chair. Now we need to write the RAG prompt. So RAG prompt is basically we need to use the we need to write use following context answer from the user and give the knowledge. Okay, so here I will be write one more thing. So they will be give the exact answer. No, if that information is not founded, give the no information founded. Found. Give the. After that I will be use my model same again here. So here my response is here. So related to the chair, they giving us specific information about the chair. So if you will be asked something else, so they will be give you the. So here you can see it's giving the exact answer that we asked from about our data, and we created one RAG system here that will be store our information, the vector data, and that will be give the exact answer of that one. So this is the difference between the LLM and the RAG. So how the RAG system will be work with the in this system. So this is for all about the RAG one here, and we will continue this session from. So this is all about the RAG system. Today we covered with the RAG and without RAG how the LLM will be work. So in the next sessions we will more go deep into the RAG systems. Thank you guys.